Okay, welcome, and this is a continuation of matrices. And in the previous videos, we looked at addition of matrices, we looked at multiplication of matrices by a scalar constant, that is. We also looked at identifying matrices by their orders. Okay, so in this video, this one will be a bit short. We are just going to look at one important aspect, which is known as the transpose of a matrix. The transpose of a matrix, which is denoted by a small letter t, or rather an underscore, not really underscore, but then a really tiny t next to the label of the matrix. Really tiny t next to the label of matrix. For example, we've got matrix A. Matrix A is equal to 2, 4, 7. Okay? So this is our matrix A, and you're asked to say find A T, like that. So usually they won't even tell you to say find A transpose. They'll just write A, matrix A with a really tiny t, or matrix B with a really tiny t. Whatever matrix you've been given, they just give you a really tiny t and say find A T. So once you see that small t, the first thing that should come into your mind is transpose. You should know to say they're asking you to find the transpose of that matrix that you've been given. Okay, so for you to transpose a matrix, you first need to understand the concept of rows and the concept of columns. If you're not familiar with those, you can go back and try and get a review of rows and columns. So when we talk of rows, rows are simply the horizontal arrangements. Then the columns are the vertical arrangements. So what is the order of this matrix that we have? What is the order of matrix A? So matrix A has how many rows? It has 1 row. Okay, and how many columns? It has 3 columns. Okay, so when we talk of transpose, when you're transposing a matrix, you're simply changing the number of rows to the number of columns. So if it has, these are the rows and these are the columns. So when you're transposing, okay, this is a row, this is a column. When you transpose a matrix, the rows become the columns and the columns become the rows. The rows become the columns and the columns become the rows. So there is a swap there. This becomes that and that becomes that. Okay, so looks like a smiling face, eh? So we've got, so if we're asked to transpose that, we're going to have a 3 by 1 matrix. Okay, we had a 1 by 3 initially, but then after transposing we should have a 3 by 1 matrix. Okay, so what do we mean? Let's look at this. Let's get into this together. We've got our matrix A to be equal to 2, 4, 7. So our A transpose will simply be equal to, the 2 will still be there. This 4 will come under the 2, and this 7 will come under the 4. So that is our A transpose. So this row has now become that column. Okay, let's look at another example. Let's say you're given matrix B. Matrix B has 2, 4, 7, 1. What is the order of this matrix? This matrix has how many rows? 1, 2. 2 rows. And how many columns? 1, 2. 2 columns. So if you're asked to say find B transpose, what would be the order of B transpose? So looking at this, it has 2 rows, 2 columns. Okay, so the number of rows becomes the number of columns, the number of columns becomes the number of rows. So considering the fact that it has the same number of rows and the same number of columns, this still remains a 2 by 2 matrix, but the values in that matrix will change, will swap positions. Okay, do you get me? The values in that matrix, the elements in that matrix will swap positions. So the ones in the rows are these ones, the ones in the columns are these ones. So this row will become a column and this column will become a row. What do I mean? The first number that we have there will still be there, 2. Then this 4 according to our original matrix, this 4 is under the 2. See that? The 4 is under the 2. But after transposing it, this 4 then comes to that side, moves to the right side of the 2. So we've got the 4 there. Okay? Then this 7 was on the right, so it comes down there. So we've got 7. Come to the second row. This 4 is there. It has become a column. This 1 was there. It will still remain there because even if we move this, it's not moving to anywhere, so it will still be there. Okay, let's look at a few more examples so that we get a better understanding of transpose. So let's say we've got matrix C, and matrix C is composed of the elements 2, 3, 7, 4, 2, 1, and you are asked to transpose matrix C. How do you go about finding C transpose? So let's look at the order of this matrix. This matrix has how many rows? 2 rows. And how many columns? 3 columns. Okay, so it's a 2 by 3 matrix, and after transpose it should then turn to a 3 by 2 matrix. Okay, so here's what we're going to have. We're going to have our 2 will still be there. This 3 was this side, so it will come down. This 7 was on this side, so it will come down. Then this 4 was here under the 2, so it will come to the left side. Then what do we have? The 2 was this side, so it will come under the 4. The 1 was on the right side, so it will come under the 1, under the 2. And when you look at this matrix has how many rows? 1, 2, 3. And how many columns? 1, 2. So it becomes a 3 by 2 matrix. Okay, so that's how we go about transpose. That's how we go about transpose. Okay, we can look at more examples, but I'm trying to save the examples that we have to look at for a later time, because we're going to have a video in which we just concentrate on examination questions on matrices. We'll go from as far as 2014 and we'll come to as recent as 2019 and see how these questions were brought and how to tackle these questions. Another thing that I wanted to mention whilst we are still rolling is on what are known as square matrices. Okay, square matrices. I believe you've at least once come across this phrase, square matrices. So what are square matrices? So in talk of square matrices, these are matrices that have the same number of rows as well as the same number of columns. The number of columns and the number of rows is the same. So I've got, let's say matrix A has 2, 3, 4, 6. So what is the order of this matrix? This is a 2 by 2 matrix. So this is a square matrix. If you've got B, matrix B, being equal to 3, 6, 9, 9, 2, 1, 4, 3, 7. This is a 3 by 3 matrix. So therefore this is also a square matrix. So that's just something that you need to know. Square matrices have the same number of rows, same number of columns, and transpose is you simply changing the number of rows to the number of columns. Rather, the elements in the rows, you are swapping them, you are converting them into columns. And that's it for this video. Thank you for watching, and see you in the next video as we continue to unpack this broad and quite interesting topic of matrices. Thank you very much.